Hi guys, Buildzoid here, and today we're going to be taking a look at something that the 11th gen Intel CPUs are actually good at. Because as we all know, looking at the reviews of the 11th gen CPUs and well, just kind of running them, uh, not very good at ambient. At ambient, these CPUs are honestly very disappointing. Like, it's $600, it's got 8 cores, and a lot of the time it's not really any faster than the 10-core 10900K. And when the 10 core, and when you have a workload that actually takes advantage of a 10 core, well, then the 10900K is faster. So, yeah, anyway, at ambient, the 11th gen kind of sucks. But for extreme overclocking, the 11th gen has actually been pretty amazing. Like it has absolutely smashed a bunch of records. It's not a full wipeout of all the different rankings that the 11900K is viable, like that all the 11900K can be in, because being an 8-core CPU, it's competing obviously against other 8-core CPUs like the 5800X. And the 5800X still has, like, even with the big frequency difference between the 11900K and the 5800X on liquid nitrogen, the 11900K does, like, there are some benchmarks where the 5800X is just kind of better. But anyway, yeah, so we're going to take a look at some of the 11900K scores. I might turn this into a regular thing. I don't know. Like, the thing is, back in the day, what got me into extreme overclocking was just looking at the crazy scores that were possible on liquid nitrogen. It turns out I just really like crazy numbers. I can't even say big numbers because there's certain benchmarks that are measured in completion time, and those get smaller. so it's just like, yeah. Anyway, let's go through this. So this submission right here, it's not really a score. This has, I think, been the thing that I've seen posted by the most news sites, and yeah, this is HiCookie's CPU Z validation record for the 11900K, and well, it's 7.314 gigahertz. I've seen a lot of people sort of I've seen this score get called a world record. It's not. The world record for CPU Z validations is held by the incredible, amazing FX8350. Actually, am I somewhere? I should be somewhere on this ranking at this point. Oh, no, wait. No, yeah, wait. Oh, they only do top 5. Oh, top 6. Oh, damn. Because I made it into the top 20 of hardware bought, so yeah. But I need to find a 8.5 gigahertz chip someday. Yeah, I need to dig up something that good. Anyway, so yeah, the world record is the FX8350. So this is just an 11900K category record, and as far as like 14 nanometer Intel CPUs go, this is actually kind of low. Um, like, and this is actually really awkward to check because, well, if we go like Intel and 10 core CPU, yeah, 10900K was all the way up at 7.7. If we go for highest 8 core, 9900K was 7.6. If we go for highest 6 core, we've got the 8700K at 7.4. Fastest quad core Intel CPU, we've got a almost 7.6 gigahertz 7740X. And I think for single core, yeah, you have the Intel Celeron D. So in the, as far as Intel CPUs go, the 11900K really doesn't clock that high, which makes sense because it's a gigantic, it's a really big core. Big cores don't tend to go very fast. Especially when you port them back. Well, the funny thing is, if they built the 11900K on 10 nanometer, it might clock even worse, right? Like that's probably the main reason they ported it back to 14 nanometer was like, well, if we make it on 10, it's never going over 4 gigahertz consistently, and that's just unacceptable. So yeah. Anyway, so yeah, HiCookie managed the 7.3, and the way he did that is just running 3 cores and one of the cores doing the max frequency, which is that's just how you do CPU Z validations. Because the thing is, with CPU Z validations, the way this works is you just have to save a validation file from CPU Z, and that's you can do that with 1 core. Like, you don't need a bunch of cores to save a CPU Z validation file. Plus, when you're doing this, the system is so incredibly unstable at this point. Well, depends how far you push it, but normally when I do CPU Z validations, I'm 20 megahertz from crashing away. It's super unstable. You're not running really like. I think the only benchmark that is capable of running at similar there's like 2 benchmarks that are just about able to run at similar frequencies to what you can run like CPU Z validations at. So this is not a by no measure is this a practical overclock. And the reason I bring that up, because even the FX 8350 record, that's just 2 cores on that chip, which that has to be a really lucky chip to have like a good core in the first 2 cores, or they're using a modified BIOS that somehow allows them to disable all but 2 modules and all but 2 cores, because normally you can't do that. Normally you're stuck with having 1 module per core and then having 4 cores, or having 1 module and only 2 cores, which is which isn't necessarily ideal, either of those options. But anyway, so for CPU Z validations, at least if you actually want to like properly max it out, in my opinion, you do it with the minimum amount of cores necessary, because any extra cores translates, because this is basically, if you have a CPU that can go to full pot and like scales properly all the way to the lowest possible temperatures, this is all about having the lowest temperature and like the cold, like keeping the chip as cold as possible while running just like as much voltage as it needs, because technically if you give it too much voltage it gets too hot and then the frequency comes down. And so, yeah, you really don't want to have any unnecessary cores. You don't want to be clocking the extra cores up if possible. And the reason I bring that up is because Asus has the 2nd place for this. And for whatever reason, and Asus has been doing this with their CPU Z validations for ages now, but I don't get why they do this. They did it with all 8 cores enabled. And also they're applying the CPU rate. Like, if they were applying the CPU ratio to just one of the cores, I'd get it. But they're applying it to all of them. And they're running this on liquid helium, and it just seems like, so you strapped a rocket to your car and a trailer. It's like it's great that the rocket, like, you'd still, maybe like if you're going this far, maybe don't run all the cores, because the justification I've heard a few times for doing it this way is that, well, it's an 8-core CPU, you should clock all 8 cores up. And my response to that is, you're not going to run any benchmarks at this frequency anyway. Like, this is not a performance test. This is a test of, can you save the freaking file with a really high frequency somewhere in the file? Like, nobody cares how many cores you did it with. At least I don't care how many cores you did it with. Especially because, like, we have all-core benchmarks. We have Cinebench R20. We have Geekbench. We have, like, actual all-core benchmarks where, we can talk about, oh, it's actually, like, the CPU performs well. But here it's just like, no, the goal is to take a screenshot of, like, I say take a screenshot, but you're saving the verification file. But the goal here is to save a file with the highest possible frequency. There's nowhere in the rules does it say you need to have all of your cores turned on. So, yeah, I don't know why Asus insists on doing it this way. Especially since they're on liquid helium, like, with less cores, they should have more of an advantage against, like, other scores being done on liquid nitrogen. So, yeah, like, to me, this is like strapping a rocket to your car and then also adding a trailer to it in a drag race. It's like, yeah, you've got more power than everybody else in the race, but, like, why did you strap a trailer to it? Like, yeah, I know the car can tow stuff, but this isn't nobody else is towing anything. So, anyway, moving on to benchmark scores that are actually just straight up impressive, and there's not really much to discuss about them. Cinebench R20, 8,302 points. The 11900K does really well here. And so this was done by Ralph on a Maximus 13 Apex. Chilled RAM, apparently. LN, CPU on LN2, of course. And the chip got up to, actually, it just says that, doesn't it, somewhere? Yeah, 6530 on the CPU. And the memory is actually running a bit relaxed compared to some of the other scores we're going to be taking a look at. So, yeah, anyway, that's what, like 50... It's 5100? Yeah, that's DDR4 5100 CL17. So actually, compared to some of the scores we're going to look at next, very chill memory settings, but yeah, the CPU is going pretty fast. Now, the thing that's sort of interesting, well, it's not really interesting. It's like that's the whole point of having an IPC increase, right? Is that you can clock lower and get more performance. The 11900K is really not the highest clocked CPU in this ranking. Like that would be like the 9900K over here, doing 6.9 gigahertz and being like 1,000 points slower. So yeah, there's a big performance uplift from the architecture updates that Intel has made to the 11900K compared to the 10900K and the 9900K, because what you need to keep in mind is the 9900K and the 10900K use the exact same cores. Actually, the 10700K use the exact same cores. So yeah, like there's a big IPC increase, at least for Cinebench R20. Because at 6.5 gigahertz, this thing absolutely just like it's not even like it's not a small improvement. Like it is absolutely demolishes the 9900K while running like 400 megahertz less core clock. So, yeah, 11900K, pretty good for Cinebench R20, assuming you're on liquid nitrogen. And then if you're wondering how Ryzen compares, well, we have a 5800X, not actually that far behind, while clocked to just 6 gigahertz. So yeah, like, well, Ryzen is, I guess, like an extreme example of having massive IPC at the cost of clock speed. And then also some of that's going to just be down to the manufacturing process. Intel's 14 nanometer has been just like Intel 14 nanometer started out as clocking like garbage, like absolute garbage. Broadwell was terrible. Then they had Skylake, and Skylake was pretty good. And then they did KB Lake, and it was like, look, it's fast now. And then they've just been polishing that since KB Lake. And so, yeah, the 11900K gets to have a massive high IPC core. I guess not as high as Ryzen, but still, it's like a big improvement over the predecessors. And yet, it still clocks really, really high. Even for like all core workloads like Cinebench R20. So yeah, 11900K, very solid for Cinebench R20. Also second place, we have the Sergman. I don't know, I'm butchering that name probably, but yeah, he's benching on a Z590 Aorus Tachyon from Gigabyte. He's managing a 6576. So he might want to rerun because Cinebench is normally just a, well, I think. Oh, right. He's running less uncore frequency. So he's running like 6 gigahertz uncore, whereas Ralph, I think, is running 6.2 uncore. Yeah. So that's probably where those 2 extra points come from. Because otherwise, Cinebench is basically just a raw CPU frequency test. And, Ralph is clocked like 20 megahertz lower, I think. Yeah, or 50. Yeah, so that uncore clock is certainly helping out a lot, because at this level, like once you're looking at scores in the top 10, you can assume that their operating systems are like properly set up. Anyway, so yeah, really solid. Like yeah, and then we have safe disk benches on Asus ROG, OGS also, Arsenino. That's also going to be an Asus. Yeah, he also uses an Apex. So, and then we have, and then Splave, that's the 5800X. So we might see, I'm guessing we're going to eventually see more 11900K scores for Cinebench R20. Anyway, moving on to the crazy memory setting benchmarks. Safe Disks Geekbench 3 multi-core score. Done on the Maximus 13 Apex. And he was running, we need to take a look at this, because yeah, he was running 5300 CL15 memory, which is absolutely insane. Putting out almost 13,000 points Geekbench like memory score. So I'm assuming we're eventually going to see like over 13,000 be a thing with 11th gen. I wouldn't be surprised because the funny thing is, if you're really trying to max out your overall Geekbench score, you're potentially gonna have to sacrifice a little bit of your memory score to do that, because like the memory score plays a big role in the overall score, but it's not the only thing that matters, right? So yeah, there's probably like there's definitely like 13,000 Geekbench memory score is definitely a thing that's already been done. I'm guessing. And the only thing is, like, there's no dedicated ranking for just the memory score, which is kind of interesting, because that's where you see like the really, really crazy really high frequency, not necessarily that tight timings for the memory, because Geekbench is really more of a bandwidth test, and you don't necessarily need the tightest of timings. But you know, CL15 at 5300 is not exactly loose. So yeah, Geekbench 3 is just great for looking at memory settings that make you go, whoa. For like this right here is just like that's some crazy memory. Um, and yeah, apparently he was using Arctic MX5. So that's interesting because I tried to run MX4 on liquid nitrogen and it was terrible. Like it was absolutely horrendous. Or well, I didn't try to use it on top of an IHS. I tried to use it under an IHS, and under an IHS, like as a like for yeah IHS to like die, MX4 just fails at like minus 60 degrees. But um, I wonder if like Arctic has decided that for MX5 they actually wanted to also be really stable at low temperatures. So that's interesting because I don't know how much MX5 costs, but I would be very surprised if it costs anywhere near as much as say Thermal Grizzly Cryonaut or what is it, KPX from Kingpin Cooling. So yeah. Anyway, this is just a hell of a score. And then Ralph, I think he was running CL14, which is why I want to look at his screenshot as well. Yeah, that was 5200 at CL14. And well, there's also the uncore frequency difference there. So like you don't see, also there's like sub timings that'll affect the memory score. So you can't just look at like CPU Z, like this CPU Z window doesn't tell the full story of how that memory score happens. But yeah, also just absolutely crazy memory settings there. Um, and then in third place we have Splave on the ASRock OC formula. I'm so excited that we were finally getting an OC formula retail again. Also, it looks like we finally have a colorful motherboard. Like I've been getting really sick and tired of all the motherboards being black, so it's just like yes, now we have a green one. But anyway, yeah. So he was running 5050, so not quite as like crazy memory settings, but yeah, I imagine we'll see that improve over time. Like we'll see, you know, everybody put up better scores up because launch day is always kind of like like nobody knows what anybody else is going to be posting, so it's like you might stop a bit early. Also, who knows how much time everybody has had to bench their CPUs, so yeah, we're probably like I would not be surprised if we see the Geekbench 3 like scores go even higher like over time. I don't know how long. There's been like when I got into extreme overclocking, like well, like I remember a time when there was like a new 3D Mark world record like every week, and it was a back and forth between like EVGA and Asus with a quad SLI setup, and that like we could see that like, and I don't think we're gonna see anything like that again because yeah, like extreme overclocking hasn't been that like I don't yeah, I've not seen any like there's not really been anything that kind of insane to happen with like scores recently. But I remember that being really cool. To sort of watch the score just creep up over the course of a week. Um but or over the course of like a couple weeks, but anyway, yeah, so Geekbench 3 is like another area where the 11900K is really strong. And then we get to SuperPi 32 million. So this is a single-threaded, very memory-intensive benchmark, and this is another benchmark where the 11900K like absolutely demolishes the 10th gen CPUs, right? And we don't actually have any, well, there's your 10th gen CPU, but that one's clocked a little bit low. Again, 10th gen and 9th gen, same core, same IPC, so, you know, whichever one's clocked highest is going to win. Admittedly, the 10th gen had slightly better memory controllers, and the record for the 10900K is actually a bit better than the record for the 9900K, as it is 4 minutes and 1 sec, like almost 1 second. The thing is, the 11900KF, on the other hand, does 3 minutes and 39 seconds, which is a huge drop in like how long it takes to run the benchmark. Like that's really fast. And yeah, the memory settings for this, like this is a more like latency intensive memory benchmark than Geekbench. Like Geekbench just loves bandwidth. You don't really need to do like as long as you're clocked reasonably high, you're probably going to get a pretty decent Geekbench memory score. And of course, having good timings makes a difference, but for the most part, it's just like clock, bandwidth. SuperPi is much more sensitive to having really optimized timings. And here we're running again 5200 CL14. It's actually a lot. I think Ralph's probably using like the same memory profile for both Geekbench and SuperPi. So, yeah, that's the thing. Like, Geekbench would normally prefer just more raw frequency. So I wonder if we'll ever see like a 5400 CL15 Geekbench run. Like, that's probably possible, considering there's already a 5300 CL15. Anyway, yeah, so SuperPi got absolutely demolished by the 11900K. So yeah, and again, like because of the IPC uplift, it's doing that at significantly lower core clocks. So yeah, on liquid nitrogen, the 11900K is actually really solid. Then we get safe disks. Oh wait, forgot that I pulled that up. So yeah, that's like a massive improvement of like 20. Yeah, like that's more than 20 seconds less time to calculate 32 million digits of pi. Also, this benchmark is insanely old. So yeah, it's been around for ages. Anyway, moving on, SuperPi 1M, which you just kind of run the same way you run 32M. At least, like, that's what Ralph did. He literally just, like, this is the same settings. Yeah, 4 seconds and 546 milliseconds. I like that. So I don't like 32M because it's too long and also very like difficult to get a good score in because it's like you need to dial in your memory, but it's also very sensitive to like setting up your operating system properly. So I'm a much bigger fan of 1M because 1M runs in like 4 seconds. So at least when the score is bad, it didn't take me too long to get the terrible score. Anyway, in second place for this we have High Cookie. And then, yeah, the old, like, 10900K clocked 300 megahertz higher, slower. Not much slower because the benchmark's so freaking fast, but yeah. Like, 11th gen is really solid if you have liquid nitrogen. Anyway, moving on to Geekbench 4. Single core. We got more crazy memory settings from Safe Disk. Oh, there's the 5400 CL14. Yeah, so the thing for Geekbench for single core. So since this is a single core benchmark, and the way this works actually is HardwareBot just looks at your like single core score. So the way you run the benchmark is you actually run it like it's a multi-core benchmark, right? So you disable, like you can see that he's disabled the CPU down to just 4 cores. Actually, we should just open that in a new window, or tab is what I wanted. No, stop being stupid. There we go. Yeah. So, you know, he is running with 4 cores. So the benchmark still runs the multi-core part, but ultimately the only thing that counts is the single core score. Yeah, because you can run it with less cores, there's actually less load, and you can run it with less cores and without hyper-threading. There's less load on the memory controller, which is why I'm guessing it was possible to run. Actually, it's like 5450 at CL15. So yeah, absolutely ridiculous memory settings. And then 7 gigahertz on the CPU, because yeah, if you're not running a big heavy multi-core benchmark, you can run higher clock speeds because you can run more voltage, and that is a lot of voltage. Is that actually like a proper voltage read? That should be a proper voltage reading. That is a hell of a lot of voltage. That's just on liquid nitrogen. Damn. That is so much. That is so much voltage. Is that like? Admittedly, like this is in the screenshot, so if he has like a droopy LLC, it's not going to be anywhere near this. Well, it is just 4 cores, so it might be drooping down to like 1.9 something, which is still a hell of a lot of voltage for 14 nanometer Intel on LN2 for like benchmarking. Then again, I wonder if he's running like 1 core, like if the overclock he's running is per core. Yeah, I guess if you're running a per core overclock, you can basically just run like insane voltages because it's like, well, the other cores are clocked down, so they're not really pulling that much power and affecting the overall operating temperature of the CPU that much. So anyway, yeah, these are some insane memory settings, and also great score. Um, it's literally at the top of the ranking. Then we have Ralph in second place with. Is he just running 52? No, also running. Yeah, and he's doing 15, 14, 14. Oh, yeah. So Geekbench 4 single core is I guess where I need to get into this then, because yeah, this is evidently less difficult for the memory controller to run. So this will be fun for messing around with like really crazy memory settings, because running Geekbench 3 multi-core, like you crash on Dijkstra when the memory controller goes like, well, you're running all your cores, so I'm just not going to be stable now. So yeah, but that doesn't matter in a single core benchmark. So this is cool. And then we've got a 5200 CL15 with TRCD 13. Which, considering we saw a 1413 at 5200, isn't really that impressive, but still, like top 3 score, just under 7 gigahertz. Yeah, like, and actually, how do the other CPUs compare? Oh, we have a 5950X in 4th place. Also just 4 cores and 4 threads. That's weird. I guess the benchmark, like, even though it's supposed to be single core, it might actually benefit from running a couple extra cores, just for like, I guess for the operating system might just be necessary because of Windows 10 being fat. Oh, and this is on dual rank memory. Interesting. Anyway, so yeah, Geekbench 4, like crazy memory settings, but ultimate, like this isn't really like a stronghold of the 11900K. That would be more like the Cinebench R20 or 32M, where AMD isn't even close. But here, like, yeah, like it's still faster than 5000 series, but like that's probably down to the fact that it can be clocked like a gigahertz higher, rather than down to the fact that the IPC is so strong. Like, yeah, you really need that extra clock speed here, right? Though admittedly getting getting 6 gigahertz on Ryzen is not easy. So yeah, actually that's the only 5950X up here. Where is the rest of the Ryzens? There's your 5950X. Intel, and then we get a 5800X all the way down here. Oh, but that one's on H2O. So I guess nobody else ran this on their AMD CPUs? That's interesting. Yeah, that's actually really surprising considering like the 10th gen chips had to be like 7.3 gigahertz and would still lose to a 6 gigahertz 5950X. Like I'd assume a 5.9 gigahertz 5800X or something would probably land somewhere in this area. Though I guess it really depends if you get lucky with your memory settings for the 5000 series. Because the biggest problem with 5000 series on LN2 is the memory controller gets really, well, even 3000 series also did this. The memory controller just gets kind of whack, and nothing works, and so then you're stuck running like really awkward memory settings. Um, so yeah, like Ryzen might still have a chance in this ranking, though I don't think it would. Well, I wonder. I really wonder. Maybe with like some extra BCLK to push it a little bit past. Actually, no, you don't even need VCLK. You could just run like 60-25 or something, like right off the ratio with AMD because they give you the fractional ratios. Anyway, yeah, so Geekbench 411, I mean Geekbench 4 single-threaded is another place where 11th gen is actually really, really capable. And then we get Y-Cruncher Pi 1 billion, which I don't actually consider this like a place where the 11th gen makes a lot of sense. And the reason why I say that is, yeah, the 11th gen has the top 3 places right now. Congrats to OGS on the first place with that. Is because, and the thing, oh my god. Oh man. Wait, that's 54. Oh, right, he's on the crucial sticks, isn't he? These are crucial. Yeah, these are the crucial sticks. Oh, and he's just running them ambient. I think he mentioned he's gonna... Yeah, he's gonna try freeze the memory sticks. That'll be really interesting to see what happens then. Because, yeah, that's the partially disabled Rev B micron ICs, and those scale with temperature. Like those properly scale with temperature. So if like I want to, I don't know what to maybe 6 gigahertz CL17. I have no idea. But yeah, that should be really interesting. Anyway, Y-Cruncher is a like very like this is a really heavy compute benchmark basically. And it's very, very memory intensive, and it takes advantage of AVX 512, and which is also why the frequency is so low, right? Like this is just 6.4 gigahertz. This is, I think, the lowest frequency out of all of the multi-core benchmarks we've looked at, and it's just because this actually uses AVX 512. It also uses a lot of RAM, so it's kind of like you can't like this is probably the most stress test benchmark out of all of the various hardware bot benchmarks. This is one of the hardest to actually like run properly, um, or more like one of the most stability intensive ones, which is why the frequencies are so low. And yeah, the memory isn't running. Like I don't think that's even max memmed because that's just 25. Yeah, that's 5100 CL17. You can probably run that without max mem, or it needs such a big max mem that you can't run better memory settings. Because yeah, it uses a lot of RAM. Um, so you can't disable like the trick to making Samsung BDI do really crazy memory settings is you have to disable most of it in Windows. So if you can't do that because the benchmark needs 4 gigs of RAM to run, yeah, you're kind of stuck with you know much less aggressive memory settings, and so that gives an edge to the Micron ICs for that kind of benchmark because, hey, what did I open? Like that gives an edge to the Micron ICs because you don't need to do that on those. They really don't care very much at all about how much memory you have available. You can just kind of run them at whatever settings are possible. Whereas with the Samsung BDI, it's like, yeah, you need to, like for, I'm guessing for like Geekbench 3, they're probably running, actually, I think you can see that in Geekbench 3. Wait, no. Geekbench, there. Like, yeah, you can see that right there. He's running 2.3 gigs of RAM on his 16 gig sticks. I mean, 16, like 8 gig sticks, not 16 gig. Yeah, so 8 gig sticks, and you know they're running just 2.3 gigs of RAM available. Um, because if you don't do that, you just don't have the stability to run settings like that. Whereas with microns, you don't need to worry about that because they don't have that behavior. So anyway, but the thing with the Y-Cruncher benchmark is just I can't help but notice that the 7820X right here is like really, really, really close to the top, you know, top 11900K scores and KF scores. And the thing is that like it's on dry ice. And it's also running, in my opinion, really relaxed memory settings. Like, admittedly, it is dual rank, at the very least dual rank, but those are some pretty chill memory settings as far as I'm concerned. So, like, I'm really surprised we haven't seen somebody just take a 7820X to like, because the thing is, if you look at other benchmarks with the 7820X on liquid nitrogen, like 5.5 should be pretty doable, like core clock. And for the memory, you should be able to run like 4200 CL14 without having to use like a crazy like the other like the thing is also the quad channel platforms have an advantage because the maximum setting like disabling the like restricting how much memory is accessible on Samsung BDI DIMMs is actually entirely like it's per DIMM. So if you have a lot of BDI, you can actually still have a usable amount of RAM. So if you have like 32 gigs of BDI, you can set like a 6 gig max mem and it has the same stability as a 3 gig max mem on 16 gigs. Um, so yeah, I'm really surprised that the 11th gen like isn't getting completely demolished by X299 CPUs here. I mean, it kind of is, except like we don't actually have X299 at the very top of the benchmark, which is the part I'm surprised about because the other benefits that the X299 has is it actually has full AVX 512 support instead of I believe 11th gen is like partial AVX 512. It's not it doesn't do everything. It has some like extra memory like I think it's mostly like memory instructions or something. Um, like it definitely helps, but yeah, I'm still surprised nobody's like maxed out like a 9800X or a 7820X on liquid nitrogen for this benchmark because that would probably be faster than all of the 11th gen CPUs, no matter how high you get them clocked. Anyway, and the last benchmark, there's PyFast. I don't know anything about this benchmark. I just know that it's like, I think it's single-threaded. It's very, as far as I know, it's also very light. Yeah, that's about it. So that's from the Asus ROG benching event. They ran it on liquid helium. And this is also like one of the benchmarks where the 11th gen isn't really doing that great. Because, like, yeah, it's faster. Barely. Right? Because second place is a 9900K, third is another 9900K, and then you've got your first 11900KF below that. Now, I guess we might see, as more 11th gen CPUs get binned, I guess this score might improve. But yeah, I unfortunately don't know anything about this benchmark, so we can't really talk about it too much because it's like, I've never run this. I kind of forget that it exists. But yeah, PyFast, a benchmark that the 11900K is actually pretty good at. And then we get to memory frequency. So the 11th gen, obviously, like 11th gen introduced the new Gear 1, Gear 2 for the memory. And as you have seen, Gear 2 for like LN2 overclocking has been absolutely amazing, allowing you to run, crazy things like 5200 CL14. And there was also that like 5400 CL15, right? Well, when it comes to just raw frequency, like raw speed, for the purpose of taking a screenshot of speed, 11th gen's really good. Like, not kind of good, like really good. This is a score from MSI. They did it on the they did it on the Z590i Unify, right? So that's the little ITX board. Yeah, with some frozen Hynix DJR memory chips, and yeah, it like Gear 2 mode go brr. At absolutely horrendous timings, but this is a CPU. Like this is the same thing as taking a CPU Z validation for CPU frequency. Well, this is CPU Z validation for memory frequency, and you run even less cores. Underclock the CPU. Like, you want the memory controller to be at under the least amount of load possible. So CPU clocked as low as possible, like literally CPU clocked as low as it goes. Disable all the cores, kill the hyperthreading, because hyperthreading makes the memory controller upset. And then, loosen out the funny thing is, you don't always want to loosen out the timings all the way. It kind of depends. Some memory chips really don't like that when you do that to them. It makes them actually like not like, some of them will literally not even boot if you loosen out the timings too much. But apparently Hynix DJR really doesn't care. And so yeah, 58, 63, 63, 2T command rate does over 7 gigahertz. And there's a few of these. Right? Like, I mean, 7 giga transfer. I should be saying 7 giga transfers, but yeah, anyway, like, yeah, 11th gen is pretty crazy for memory speed. So, and we should be seeing more scores come in for that. Because right now we have one, I think, these are all MSI as far as I know. Yeah, that's an MSI. I'm pretty sure the second place is also MSI. Oh no, that's an Apex. Okay, so yeah, so we have Asus in second place. Oh, apparently you can go lower than just 15x. Apparently it's also not necessary, because that's currently the highest score, and then that's an Asus score. So we've just got 2 Asus scores and two MSI scores at the very top right now. But I'm like, I fully expect like ASRock and Gigabyte to eventually post scores up there. Actually, I do have the Tachyon, and I do have some actually, I have kind of a lot of Hynix DJR at this point. The main issue is I don't have an LN2 pot for memory. So I don't know how exactly, like, I'm not well, I wonder what temperature is necessary. If it's just like minus 70 on the memory sticks or something, then I could just buy dry ice and do it that way. Because you can literally just bury a memory stick in dry ice, and that kind of works. If you don't need it to be like super, super cold, and you also don't mind the fact that you can't control the temperature because it's just at whatever temperature it happens to end up at. But, yeah. Anyway, so yeah, 11th gen is beast for memory frequency. And then it's also apparently really good for 3D Mark 03. And this is a benchmark that I do know exists, but I'm not good at and don't run. Um, so 3D Mark 03, very popular with a lot of people at Hardware Bot because this is like it's very old. The 03 is from like it comes from 2003. And the crazy thing about this benchmark is like it's very old, and so it's very CPU like it's very CPU dependent, right? You want your CPU going really really fast, like 7 GHz levels of fast. But the crazy thing is, even though it's a really old benchmark that runs on the GPU, it still scales with GPUs. So, not only do you have to run your CPU at like 7 gigahertz, this is a 3090 doing 2.8 gigahertz core in order to run a benchmark from 2003 and then get the record in it. Um, so, yeah, congratulations to Ralph on that. Because so LN2 GPU, LN2 CPU, and I guess somewhat chilled memory, or he's just using the LN2 pod on the memory sticks for temperature control or temperature stability. Um, but yeah, so this is a really wacky benchmark because it's like it loves GPU power, it loves CPU power, and it's ancient, which is like that's not normally the case. Most old 3D benchmarks just turn into a CPU test because the GPU is so fast that it just ends up stalled on the CPU not being able to feed the GPU fast enough. But 3D Mark 03 is the exception, right? Like yeah, like you've got top end GPUs pushing very high clocks in like the top 4. Um, and yeah, actually, like just well, even top 10, right? Admittedly, some of these are very like old, significantly older GPUs, but yeah, it's an intro. Well, also these scores are much lower, right? Like that is way less points. That's like 100. That's all. Yeah, that's like 80,000 points less. With the 1080 Ti's down there. Um, so yeah, 11th gen is like really good for 3D Mark 03. And the crazy thing about O3 is also you can run it with multiple GPUs. Now, when you run it with multiple GPUs, it becomes more of a CPU benchmark because, it becomes more of a CPU benchmark than a GPU benchmark because, well, there's overhead with like running multiple GPUs. Um, and so that's how you end up in this situation where it's like, well, the dual GPU score is lower than the single GPU score, and that's just entirely from the overhead of running extra GPUs. And then you get your 3 GPU score, which is also slower, which was done on a bunch of 7970s. And the reason why it's done on 7970s or like on AMD cards is because you can't run SLI on a like you can't run 3 NVIDIA GPUs on a motherboard like this. SLI gets very upset if you don't give it X8. Oh, come on, I want the image of the board. Anyway, so yeah, you could also run this on like 290Xs with like a 295X2 as your secondary card. So here, this is a 7990 and a 7970, which is just considered three-way 7970s because you can't three-way 7990s. And then for the two-way score, well, that was done on 3090s because again, like it does scale with the GPU. So for where you can, you want to use the fastest GPUs possible, though. I think the triple core, the triple GPU category does well. Splav's on 290Xs, and that's a 9900K score. So I guess yeah, we should see some competition in this eventually. Because I think OGS is currently like one of the first people to run this on an 11900K with 3 GPUs. So that's just a matter of time. There's probably going to be more scores coming there. I wonder what the 4-way score is, though. Ah, 9900K. Anyway, so yeah, that's kind of it for the video. 11th gen is actually really cool for LN2 benchmarking. Assuming you get a good CPU. I'm not sure how consistent 11900Ks are going to be. 11700Ks are probably terrible on average. That doesn't mean you can't have a good 11700K. It just means on average, if you like binned 100 or 1,000 700Ks and 1,000 11900Ks, you might find that on average an 11900K is like 100 or 200 megahertz faster. That doesn't mean you couldn't have a 11900K that's worse than an 11700K, right? Like that kind of thing. But um, yeah, which is kind of annoying because 11900Ks are really freaking expensive, right? They're $600 CPUs and only have 8 cores. But hey, they're great for benchmarks, assuming you have liquid nitrogen. Um, so yeah. Anyway, this is just a very weird video that I kind of thought would be cool to do because, yeah, it's like these scores go up and you don't really see people like take a look at them and talk about them and yeah, I like, well, I don't know, I like the occasionally I see like like yeah, news about how some CPU broke some record or something. And normally, like, it's just kind of, yeah. Um, and anyway, so I'm just trying this format. I think I also need to figure out some way to not make it 45 minutes long because that's kind of dumb for just looking at various scores on hardware bot. Um, but yeah, in the future, I might not like, in the future, I might just do like a couple benchmarks at a time or something. I don't know. Um, Like if there's a, I guess we could do it like if there's a big like every time there's a couple scores that got like significant improvements, I can cover those or something. I have no idea. Or maybe everybody thinks this is stupid and I'm never gonna do this again. Like that's also an option. But like this is what got me into extreme overclocking was just looking at scores like this, going like, oh my god, that's so cool. I want to do that someday. And well, I am doing it, but I'm bad at it. Right? Like the only top 20 finishes are like raw frequency stuff because you don't need to be like raw frequency. So memory frequency and CPU frequency are like the only top 20 scores I have, I think. And I guess some GPU, well, no, because the GPU benchmarks are always like assuming you're running specific GPUs. Um, yeah. So anyway, that's it for the video. I'd love to hear your thoughts on if you think this is a cool video format. Like maybe I could find some way to actually get some input from the people who actually made the scores. Um, just like if yeah, like I could maybe get some input from the people who actually made the scores because I think that it's cool. Anyway, um, yeah, but I'd love to hear your thoughts on if you think this is a dumb idea or a good idea. It won't be like an everyday thing, of course. Like I'm thinking maybe I'll just do it once a month, like a hardware bot score, like top score update for maybe just globals or something. Like maybe just for like global points because there's like different categories for benchmarks. Like there is a lot of benchmarks on hardware bot. Um, a lot of benchmarks. So many that it won't even load. I wasn't being serious about that. Please load. Can I? Oh, well. Right, did I, is that? Oh, okay. So just the benchmark page is. Oh, now it loaded. Yeah. So there is a lot of benchmarks on hardware bot, and obviously it doesn't make sense to talk about all of them, but I do think it would be kind of cool to give some extra coverage to like top competitive like top scores for uh on hardware bot because well, a unwritten goal of the AHOC channel is to actually get more people into competitive overclocking. Um, why, yes, I do shill for Lind gas. No, I don't. Um, but yeah, anyway, so I'd love to hear your thoughts on if this is a good or bad idea. And that's it for the video. So thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I do have a Patreon and a Patreon. There's a link to that down in the description below. There's also the HOC Teespring store where you can pick up shirts, stickers, posters, the usual YouTuber merch. And both of those help out immensely with running the channel. So it would be much appreciated if you check those out. And yeah, that's it for the video. Thanks for watching and goodbye.